Today's lesson is going to be over solving absolute value inequalities. Okay, when we talk about absolute value inequalities, what they're talking about is the distance you are from zero. And with inequalities now, they're telling you that you have to either be greater than this distance from zero or less than this distance from zero. So this absolute value of x, the absolute value of x, has to be greater than or equal to 4. So it has to be the number x, the distance it is from 0, has to be bigger than or equal to 4. So let's go ahead and graph this on a number line and take a look. So the distance we're supposed to be is 4 from 0, but we have to be bigger than 4 from 0. Well, I know that 4 is 4 from 0. I also know that negative 4 is 4 from 0. So what that's telling me is, if I have to be more than 4 from 0, well, anything between 0 and 4 would be less than 4 from 0. So everything outside of 4 will have to be more than, this will be more than 4 from 0. And the same thing for negative 4. Negative 4 is exactly 4 from 0. Anything less than that will be less than 4 from 0. And it says that we have to be greater than or equal to 4 from 0. So we're going to be somewhere out in here. This is how we're going to set up our inequalities. This is how we set up our absolute value inequalities every single time. So it says the absolute value of x is greater than or equal to 4. Well, now I've set up my two inequality signs. It could be equal to 4. I could be 4 from 0 on both these. But I need to be greater, the distance needs to be greater than 4. So I can set up an inequality here. This would be x has to be greater than or equal to 4. And then, or, notice this is an or, this is not an and, because we don't have them, they're not intersecting solutions. Or, x is going to have to be less than or equal to negative 4. Alright, because the numbers are less than negative 4. And this would be our answer right here. Now, obviously, we want to graph this on a number line when we're finished, but we already have the number line here because this is one of the easier type of problems to solve. So let's look at this now, this problem over here. It says that our distance from 0 has to be less than or equal to 12. So negative 2x in the absolute value, negative 2x has to be less than or equal to 12 from 0. So we have to be less than 12 from 0. Let's mark on the number line all the numbers that are 12 from 0. So I know that 0 is here, this is 12 from 0, and negative 12 is 12 from 0. So it says less than 12 from 0. Numbers that are less than 12 from 0 would be like negative, or like 11, 10, 9. Those would all be less than 12 from 0. And it says it could be equal to, so I could be equal to 12, and I could be equal to negative 12. But all the things that are less than 12 will be in here. This is less than 12. And we also know negative 12, you would have to be between negative 12 and 0. So now you notice that these solutions are coming together. They include 0. This would be an AND problem. So let's write our inequalities based on this. This is negative 12. It could be equal, but the numbers have to be greater than. So x, so negative 2x has to be greater than or equal to negative 12. But on this side, and this would be an AND problem, you would have to be x, or negative 2x could be less than or equal to 12. So negative 2x greater than or equal to negative 12, or negative 2x less than or equal to 12. So now we're going to find the x values that work for this. Let's divide by negative 2. Whenever you divide by a negative, remember you flip the sign, so x is going to be less than or equal to 6. And divide by negative 2, divide by negative 2, flip the sign, so that's going to be x greater than or equal to negative 6. Now these are not the distances from 0, remember, these are the x values that if we plug them in to the absolute value equation, they would satisfy this solution. So if I plug 6 in, that's negative 2 times 6. Negative 2 times 6 would be negative 12. Absolute value of negative 12 would be 12, and 12 is less than or equal to 12, so that worked. If we plug in negative 6, it says x greater than or equal to negative 6, plug in negative 6. All right, again, negative 2 times negative 6, that would give us a 12, and then we could, negative 2 times negative 6 would give us a 12, and 12 is less than or equal to 12. So let's graph this on the number line real quick. We would have to be 0. This is -6. This is 6. X less than or equal to 6. That means from right here, the solutions would be, put a bold line, solutions would be right in here, draw an arrow. X greater than or equal to -6. Bold line, greater than or equal to, right in here. And it's an AND problem, so the solutions would be in here. So if you plug in any numbers between -6 and 6 into this equation, it will satisfy it. Now let's take a look at two other problems, and we'll just go through these pretty quickly. We want to get rid of the stuff on the outside, so we're going to subtract 5 from each side, and that gives you the absolute value of 5x less than or equal to 40. Now the absolute value of 5x, all right, in this case, your distance from 0 has to be less than or equal to 40. So we're going to mark on here where 40 and -40 would be. So 0, 40 here, -40 here. These are both 40 from 0. All right, the distance from 0 is 40. Now it says that it has to be less than or equal to 40. Well, distance is less than or equal to 40, so -40, that means less than or equal to it would have to be right here, because these are the distances that are less than 40 from 0. And right in here, this would be distances that are less than 40 from 0 here. Notice this will be an AND problem. So at this point, we need to write our inequality sign, or our inequalities. Remember, they could be equal to 40 from 0. So in this case, well, I say that x has to be greater than, 5x has to be greater than or equal to -40, and 5x will have to be less than or equal to 40, because it's an AND problem with a shade in the middle there. Now you can solve each of these. Divide by 5, divide by 5. You end up with x greater than or equal to -8, and divide by 5, x is going to be less than or equal to 8. Now we can draw that on a number line just to show it. So if we draw it on the number line, we end up with greater than or equal to -8. So -8 is here, 0 is here, 8 is out here. This is a bold dot going to the right, and then less than or equal to 8 is a bold dot going to the left. So the solutions are in the middle. And finally, let's look at this problem here. This one looks like it's going to be a no solution problem, but remember, we have to get rid of this stuff first. So we're going to subtract 5 on each side. That gives you -8, absolute value of -2n, greater than or equal to -80. Now notice we got a negative still out here. We're divide by -8, and guess what happens to the negative sign? It's going to switch. All right, it's going to flip to a positive. So that's going to cancel there. So we get an absolute value of -2n. And then the sign flips as well, less than or equal to 10. Now we could actually solve this. We're 10 from 0. It says less than 10 from 0. So if we mark -10 and 10, less than 10 from 0, numbers that are less than 10, well, this is 10 from 0. So less than 10 from 0 would be in here. This is 10 from 0, so less than 10 from 0 would be in here. So that means that I have an inequality. It could be equal. I have an inequality that's a -2n, has to be greater than or equal to -10, and I have -2n, which has to be less than or equal to 10. Now if I divide by -2 on each of these, that will end up giving me n. When you divide by negative, flip the sign, so I'll end up with n less than or equal to 5, and n greater than or equal to -5. If I do those on the number line, this is 0, this is -5, this is 5. We're going to go close dot here, n less than or equal to 5, go in this direction, n greater than or equal to -5, go in this direction. So the solutions would be in here.